Io. Galileo Galilei discovered Io in 1610, and 4 centuries later, it remains one of the most extraordinary and dangerous moons in the solar system. Orbiting Jupiter at just 421,700 kilometers, Io is caught in a gravitational tug-of-war with the gas giant and its neighboring moons Europa and Ganymede. This relentless tidal flexing generates immense internal heat, powering more than 400 active volcanoes across its surface. Voyager 1's flyby in 1979 provided the first direct images of sulfur plumes rising 300 to 400 kilometers above the landscape, confirming Io as the most volcanically active body in the solar system. Lava flows stretch for hundreds of kilometers, constantly resurfacing the moon and erasing impact craters that would otherwise accumulate. Europa. Discovered by Galileo in 1610, Europa spans 3,100 kilometers in diameter and is encased in an ice shell believed to cover a global subsurface ocean. Data from NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, confirmed compelling evidence of liquid water beneath its fractured icy crust. The surface remains frozen at -160 degrees Celsius and endures constant bombardment from Jupiter's intense radiation belts, rendering it uninhabitable at the surface. Yet models suggest hydrothermal vents on the seafloor could provide heat and energy sources, creating environments where microbial life might persist. These conditions have made Europa one of NASA's highest priority targets in the search for extraterrestrial biology, leading directly to the upcoming Europa Clipper mission set for launch in the 2020s, Ganymede. Ganymede, discovered by Galileo in 1610, is the largest moon in the solar system with a diameter of 5,268 kilometers larger even than Mercury. Unlike any other moon, Ganymede generates its own magnetic field, a feature typically associated with much larger planetary bodies. Beneath its icy surface lies strong evidence of a vast saltwater ocean, potentially containing more water than all of Earth's oceans combined. In 2015, the Hubble Space Telescope observed auroras oscillating around Ganymede's poles, their shifting patterns best explained by the influence of a conductive liquid ocean beneath the crust. These findings make Ganymede a compelling candidate for habitability studies, as its hidden ocean could provide stable conditions shielded from Jupiter's radiation. Callisto. Callisto, the outermost of Jupiter's Galilean moons, discovered by Galileo in 1610, spans 4,821 kilometers and displays one of the most heavily cratered and ancient surfaces in the solar system. Despite its battered exterior, magnetic signatures detected by the Galileo spacecraft suggest a hidden subsurface ocean, raising interest in its potential for astrobiology. Unlike Io or Europa, Callisto orbits farther from Jupiter's radiation belts, making it the most radiation-safe of the major Jovian moons. This relative safety, combined with its stable geology, has led NASA to propose Callisto as a possible site for future human bases or way stations. Its calm, ancient environment offers a striking contrast to the volcanic violence of Io and the oceanic mysteries of Europa and Ganymede. Enceladus. Enceladus, a small Saturnian moon only 504 kilometers across, stunned scientists in 2005 when NASA's Cassini spacecraft detected towering plumes of water ice erupting from fractures near its south pole. Subsequent analysis revealed that these plumes contained organic molecules, hydrogen, and methane, all key ingredients for potential life. The findings pointed to a global subsurface ocean beneath Enceladus's bright icy crust, kept liquid by tidal heating from Saturn's immense gravity. With its accessible geysers venting material directly into space, Enceladus has become one of the most promising locations in the solar system to search for extraterrestrial life. Titan, Saturn's largest moon, at 5,150 kilometers in diameter, is the only moon in the solar system with a thick atmosphere, composed primarily of nitrogen with traces of methane, and exerting surface pressure 1.5 times greater than Earth. In 2005, ESA's Huygens probe, carried by NASA's Cassini spacecraft, descended through Titan's orange haze, and became the first lander to touch down on a moon of Saturn, revealing a frigid landscape shaped by erosion and rivers of liquid hydrocarbons. Radar mapping confirmed the presence of vast lakes and seas of methane and ethane concentrated near the poles, forming a unique hydrological cycle entirely unlike Earth's methane. Complex organic molecules detected in the atmosphere suggest that Titan could host prebiotic chemistry, mimus. Mimus, discovered in 1789 by William Herschel, is a small Saturnian moon just 396 kilometers across, instantly recognizable for its massive 130-kilometer-wide Herschel crater, which earned it the nickname Death Star Moon. While long assumed to be geologically inert, Cassini data revealed unusual libration, or wobbling, in its rotation that suggests hidden internal complexity. Some models propose the existence of a subsurface ocean beneath its icy shell, an unexpected possibility for such a small and cold body. Others argue that the anomalies might result from an elongated rocky core rather than liquid water, leaving the debate unresolved. If confirmed, an internal ocean would elevate Mimas from a frozen relic to another candidate for habitability in the Saturn system. Miranda, a small Uranian moon just 471 kilometers in diameter, was discovered in 1948 by astronomer Gerard Kuiper and revealed in striking detail by Voyager 2 during its 1986 flyby. The spacecraft's images showed one of the most bizarre and extreme landscapes in the solar system, with canyons plunging as deep as 20 kilometers, nearly 10 times the depth of the Grand Canyon. Miranda's surface appears like a patchwork quilt, with regions of heavily cratered plains stitched alongside vast ridges, cliffs, and young resurfaced areas, leading to its nickname as the Frankenstein Moon. Scientists believe this chaotic terrain may have formed through repeated episodes of disruption and reassembly, possibly caused by past tidal heating, when Miranda's orbit was more eccentric. Its strange geology highlights the dynamic processes that can reshape even small, distant moons. Charon. Discovered in 1978 by James Christie, Charon is Pluto's largest moon, measuring 1,212 kilometers across roughly half the size of Pluto itself, making the pair more of a binary system than a planet and its satellite. In 2015, NASA's New Horizons spacecraft provided the first close-up images of Charon, revealing immense canyons stretching 1,600 kilometers across its surface and plunging up to 7 kilometers deep. These features suggest powerful tectonic activity in the past, possibly linked to the freezing and expansion of a once liquid subsurface ocean. Unlike Pluto's smoother plains, Charon's fractured landscape preserves a record of ancient upheavals, offering scientists clues about the internal evolution of icy bodies in the Kuiper Belt. Phobos. Phobos, the larger and innermost of Mars's two moons, was discovered in 1877 by American astronomer Asaph Hall and measures only 22 kilometers across, orbiting just 6,000 kilometers above the Martian surface, closer than any other moon in the solar system. To its parent planet, Phobos completes an orbit in less than 8 hours, rising and setting on Mars twice each day. Its heavily cratered surface includes the massive Stickney crater, which dominates one hemisphere, and long parallel grooves that scientists believe result from internal fracturing caused by tidal stress. Because its orbit is slowly decaying, Phobos is gradually spiraling inward and is expected to either crash into Mars or break apart to form a ring in 30 to 50 million years. Dactyl. In 1993, NASA's Galileo spacecraft made a landmark discovery when it photographed a tiny, 1.4-kilometer-wide moon orbiting the asteroid Ida, later named Dactyl. This was the first confirmed asteroid moon ever detected, proving that even small bodies in the solar system can host satellites. Dactyl orbits Ida at a distance of about 90 kilometers, and its presence immediately challenged existing models of how such systems form. Some scientists argue it may be a captured fragment, while others propose that it coalesced from debris created during a massive impact on Ida. The discovery reshaped asteroid science by showing that binary and multiple body systems are far more common than once believed. Dactyl's unresolved origin continues to highlight the complexity of small body dynamics, leading naturally to other puzzling moons with chaotic rotations and unusual surfaces. Hyperion. Discovered in 1848, Hyperion is one of Saturn's most unusual moons, measuring about 270 kilometers across and orbiting in resonance with Titan. Unlike most regular satellites, Hyperion tumbles chaotically through space, with no fixed rotational period, making its orientation unpredictable from one orbit to the next. Cassini's close flybys in the mid-2000s revealed a porous, sponge-like surface riddled with deep craters, giving it an otherworldly appearance unlike any other known moon. Its density is so low that scientists conclude it is composed mostly of water ice mixed with minimal rock, leaving large voids within its interior. Even stranger, Cassini detected that its surface can become electrically charged, with electrons accumulating under the influence of Saturn's magnetosphere. If you enjoyed this, I'm going to be posting a lot here. I would greatly appreciate it if you could subscribe. Thanks for watching.